Okay, lesson 4.5, proving triangles congruent by side, angle, side, and hypotenuse length. Okay, so warm-up exercise. You are given, oh, I just turned my Promethean slate off. You are given DF bisects CE, creating, and you're told that DC is congruent to DE. Now, because this bisects, you're supposed to remember that those two would be equal. Bisects means breaks it in the middle. They want you to prove that CDF is congruent to EDF. Well, DF is going to be congruent to FD. So now I have three sets of equal sides. So by side, 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 I can prove that they are congruent. That they are, congruent triangles. Okay? So today we're learning about side, angle, side congruence. Okay? And you can go through and read this and fill in your guided notes so that you know what's meant by included angle. And for our first one, we're going to write a proof. We're going to do it together for the side, angle, side congruence postulate. So we are given BC is congruent to DA, and we're told that they are parallel. They want us to prove angle ABC is congruent to triangle CDA. Did I say angle? Triangle ABC. So the first two are given. BCA is going to be congruent to DAC, correct? From the alternate interior angles theorem. Now also they didn't use it here, but we can say, but BAC is going to also be congruent to DCA from alternate interior angles theorem. The reflexive property of congruence, AC, is going to be congruent to AC, so I'm going to give that 2 lines. So side, angle, side. So side, angle, side, that's the included angle, and side, angle, side, the included angle shows that these two triangles are congruent. So we used it in a proof. Example 2, in this diagram, QS and RP pass through the center of M. You should know that obviously SM and MQ and RM and MP are all going to be equal because they're all basically radiuses, radii, from the center of the circle to the end of the circle, okay? So if this and this and this and this are equal, I have two sets of sides that are equal. I know that angle is congruent to this angle because they're vertical angles. So through the side, angle, side, congruence postulate, I know that these two angles must be congruent. Okay? So guided practice number 3 and 4, they ask you to actually do some proofs. We're going to walk through these together. Okay, so they tell me that ABCD is a square with 4 congruent sides. That makes sense. A square would have 4 congruent sides. R, S, T, and U are midpoints. So that means this and this are going to be congruent. This and this are going to be congruent. These are going to be congruent. These are all going to be congruent. Okay? Also, RT is perpendicular to SU. So that's going to mean these are all going to be right angles. And SU, now this is a mess up here. This should say, I think SV. V is congruent to VU. SU is definitely not congruent to VU. So I think that's a typo there. That is, SV is congruent to VU. They gave you that. And SVR and RVU, actually all of these are right angles because that's the definition of perpendicular lines. Perpendicular lines intersect to make right angles. So also I can know that RV is congruent to RV. So they wanted me to prove here, I'm going to highlight this, that triangle SVR is congruent to UVR. So I have congruent sides, I have congruent angles. Obviously RV is congruent to RV. So the side angle side postulate tells me that they are all congruent to each other. Okay? And for number 2, they want me to prove that triangle BSR is congruent to DUT. Okay? Well, if you remember from before, all of these sides are congruent. So I'm going to go ahead and mark them up here. Pen, blue, this and this are congruent, this and this are congruent, congruent, congruent. So I have 2 sets of sides that are congruent. Okay? RBS, these obviously have to be 90 degrees. Because I was told that these are perpendicular lines. Also, I was told that this is a square, and the definition of a square is that these are right angles. So from side, angle, side, I can prove that these 2 are congruent. Okay? In general, if you know that the 2 sides and the measure of an angle not included, you can create 2 different triangles. So side-side angle is not going to be a method way of proving. There is a special case, though, with the right triangles called leg hypotenuse. So we're going to go through that. Okay? If the hypotenuse and the leg of a right triangle are congruent in one triangle, in one right triangle, and then you know that the triangles are congruent. So this is a unique case where it's side-side angle, but it works because it's a 90-degree angle. Remember, side-side angle is not generally a valid method for proving triangles are congruent. So let's use this concept to form a proof. So they told us that WY is congruent to XZ. Okay? And they told me that WZ is perpendicular to ZY. So that's going to be a 90-degree angle. And this is going to be a 90-degree angle. Okay? They told me that this side is congruent to this side. And since ZY is reflexive to ZY, I'm going to be able to prove this through hypotenuse length. So I said Z and Y are right angles. Okay? WYZ and XZY are right angles. Are right triangles. I can see that. That's the definition of a right triangle. I have the reflexive properties. So once again, I proved these are congruent. Hypotenuses are congruent. The legs are congruent. It's a right triangle, so it meets the qualifications for proving triangle congruence through the hypotenuse length congruence theorem. So now, for example, 4, they want me to choose a postulate or theorem. You can read this whole problem here. You know that RP and QS are perpendicular. This is a 90-degree angles. Okay? So this is a side. This is an angle. This is another side. So you can prove that they are congruent through side, angle, side. Could you end up probably finding a way now to prove that since they're congruent, these are congruent? You could find some things and prove it by hypotenuse length, but it's much quicker to prove it through side, angle, side. So, guided practice number 3. They want you to redraw the diagram to show them corresponding, so that you can mark up the corresponding sides. Okay? These don't look congruent, but we're told that AC and BD is congruent. So since we've marked that congruent, okay? They're both right triangles. BC, okay, is going to be congruent to BC. So I've shown that the hypotenuses are congruent. I've showed that one of the legs are congruent, even though it doesn't look like it. and there are right triangles, so by hypotenuse length congruence theorem, they're going to be congruent. And we can kind of go through that. B and C are congruent, the definition of perpendicular lines. You could actually say angle C and angle B are both right triangles. That's actually what, are right angles. That's what I would say. Definition of a right triangle. Oh, I don't know why that's drawing. I wasn't even on the board. And we have hypotenuse length congruence theorem. Okay, so now daily homework quiz. Is there enough information to prove the triangles are congruent? Well, we have sides that are congruent, one set of sides, two sets of sides, and the included angles. So there is enough information to prove that we actually were talking about A, B, E, and C, B, D, okay? But still, this is congruent to this is congruent, okay? So AB is congruent to CB, BE is congruent to BD, and since these angles are congruent, the fact that they share the same amount, I can prove that ABE is congruent to CBD. There is enough information through the side angle side postulate. Is there enough information to prove the triangles are congruent? Well, they're both right triangles. They have a congruent hypotenuse, and they have a congruent leg. So even though you're not sure if they're congruent, there is enough. They are congruent through the hypotenuse length congruence theorem. State a third congruence that would allow you to prove RST and XYZ by the side angle side congruence postulate. So ST is congruent to YZ, and RS is congruent to XY. So you would need to show that angle S is congruent to angle Y to be able to prove this through side and side. And a third congruence that you would need here, they tell you that T is congruent to Z. They tell you that RT is congruent to XZ. So you need the side angle side. So you need that ST is congruent to YZ. Okay? And now you can go ahead and do your homework for lesson 4 or 5. Oh, I think I have that page twice. Okay, so there you can flip through, see all the pages, and you can do lesson 4 or 5.